This project aims to automate the detection and recognition of handwritten marks from scanned images and PDF documents by leveraging machine learning and computer vision techniques. So, what we give input? Image files. We can give .png, .jpg, .jpeg, and also the PDF files .pdf. As an output, we will receive rows representing questions like Q1, Q2, Q3, Q5, etc. Columns representing A, B, C, D, E, and total. The total column will display the sum of scores for each question base and the detected digits. So now we will talk about the technologies required. First, Python. As we can see, we can code this in Python, the primary programming language for developing the application. Streamlit, a web application framework that allows for easy creation and interactive web application using Python, TensorFlow, and Keras, a deep learning library used to build and train the model for digit recognition. A computer vision library, OpenCV, for image processing tasks such as image resizing, thresholding, and contour detection. NumPy, a library for numerical computation that is used to handle data and perform mathematical operations. Pandas, a data manipulation and analysis library that is used to create and export data to Excel. And PyMuPDF fits, a library for PDF extraction that allows the application to read image from PDF files. So we can see this is my app.py file in which I have coded full code, where there is my full code. You can get it from my Git repository. And this is my model which I have trained to detect numbers from the PDF and image file. So now we can start. So to run Streamline, we can give this command. Where is this? Once again, Streamline and app.py. So the browser will open. So it shows that my AI model is loaded successfully, and now I will select the file which I have to detect marks from. Example, I have selected this file. It is processing, and in background we can see it is working. It takes time. So by clicking download, we can download it in Excel format. And this is our marks which we are extracted from the image. So now we will see how it works. So first, when the first process is image processing. Each image, whether extracted from PDF or uploaded directly, undergoes several processing steps. Blurring. The image is blurred using a Gaussian blur to reduce noise and improve the effectiveness of edge and detection. Thresholding. The image is converted to binary using adaptive thresholding, highlighting the handwritten marks while making the background white. Contour detection. The application identifies the contours in the threshold image to locate regions where digits are present. This is done using OpenCV, which is powerful library for image processing. Now the next step is digit recognition. For each detected contour that meets size criteria, the application extracts a region containing a digit that prepares it for prediction. So for example, to detect this 4, this cell is extracted and then it is detected by using our Keras model. The extracted digit images and resized to a standard size and normalized scaled to value between 0 and 1. The pre-processed image are fed to a pre-trained deep learning model. For digit recognition, the model predicts the digit in the extracted region based on its training or similar handwritten data. So first, we have to train our data set, and then by accuracy, it can detect it is 1 or 2 or like that. Result compilation. The detected digits are compiled into a structure format that summarizes the marks. Like this is summarized, this, not this, another image is summarized in this table. So we can see the marks are written in these tables, and then the final output we get in Excel format. So now we will talk about the libraries which are used. First is Streamlit, a web framework that allows you to create interactive web application using Python. It handles the user interface, file uploads, and interaction seamlessly. Then we can CV2, which is OpenCV, an open source computer vision library used for image processing tasks. It provides further for image manipulation, contour detection, and various image transformation. Now we can see NumPy. NumPy is used computer to provide support for arrays and matrices. It is used for data manipulation, especially in handling images data and compiling result. Now we can see TensorFlow, a deep learning library used for building and training the model that recognizes handwritten digits. Keras, which is a part of TensorFlow, provides a high-level API to simplify model development. So then now we can see OS, which is an operating system. Now we can see Pandas, a powerful data manipulation library that allows for easy creation, analysis, and export of data to various formats, including Excel. Now we can see Fits and library for working with PDF files. It allows the extraction of images from PDF documents, which is essential for processing scanned pages. So the summary of our project. The project integrates several libraries and technologies to create a streamlined solution for detecting and processing handwritten marks by leveraging computer vision and machine learning. It automates a traditionally manual process, providing user with an efficient way to dignitize and analyze handwritten data. Thank you.
I will show you to work with MNIST handwritten digit dataset from Kaggle. You will learn how to download the dataset, train a model to recognize handwritten digit and apply it in your projects. To begin with, we need to download the MNIST dataset from Kaggle. This requires setting up the Kaggle API on your local machine. Start by heading over Kaggle website and under account settings, download your API token, a file called kaggle.json. So this is our Kaggle website. When you search it, it will appear like this, and there is your username. You can log in, and then you can go to settings. Here you can see create new API token. After that, you can download .json file from Kaggle. Once you have kaggle.json, move it to the proper directory where Kaggle expect it to be, typically in your .kaggle folder. With this Kaggle API setup, we can now download the MNIST dataset. Dataset consists of thousands of images of handwritten digits labeled from 0 to 9. We will use these images to train our model. So I have already downloaded it. You can see it here, mnistin.csu.zip. You can download it and then extract it, and then you can use it. Now that we have the dataset, let's load and prepare it for training. We will split the data into training and validation set to ensure that our model can generalize the new data. So we can, after it, we can run it. So now you can see our model is training. With our model architecture setup, we can now train it on the MNIST dataset. The training process involves feeding the model thousands of handwritten digits images, allowing it to learn pattern associated with each digits. Once training is complete, we evaluate the model performance on the validation set. We look the metrics such as accuracy to measure how well the model recognizes handwritten digit. So it will take time. So I will stop it right now. You can train it till 10. Now that our model is trained, let's apply it to recognize new handwritten digits, we can test the model by giving it unseen images of digits and watching it to make predictions. So you can see as I have saved my model as handwritten marks model.h5. So we can use it in our different projects. Like I have used it in my marks detection project. Like you can see, I have specified my handwritten marks model.h5 path in my main project, so by which it can identify the digits and can convert and then convert it into Excel. And that's how you can use Kaggle's MNIST dataset to train a CNN model for handwritten digit recognition. This is a great foundation for other projects involving image recognition. So now we will see how I uploaded it on website. So I use Streamlit. Streamlit is an open source Python library that makes it easy to build and share data driven web application in minutes. It's designed for data scientists and machine learning engineers who want to create interactive dashboard and application without needing web development experience. With Streamlit, you can quickly turn Python script into web apps. It handles the front end and back end, allowing you to focus on your logic. Let's look at some key features that make Streamlit so useful. Streamlit is simple to use. You don't need to know HTML, CSS, or JavaScript to create an interactive app. All you need is Python. By writing a few lines of Python code, you can create widgets like sliders, button, and file uploaders. One of the most powerful features of Streamlit in real-time interactive, whenever a user interacts with a widget, Streamlit returns the script updating the output instantly. This makes it perfect for building interactive machine learning apps and dashboards. Streamlit integrates seamless with popular Python libraries for data science and machine learning such as Pandas, NumPy, Matplotlib, and TensorFlow. This means you can visualize data, plot charts, and display machine learning results without any additional steps. Another great feature is the ability to upload files and take user inputs. You can build application where users upload files like images, PDFs, or Excel sheets, process them in the backend, and return the result in real time. So now I will show you. First, you have to import Streamlit, and then you have to write code, and then you can build buttons, sliders, etc. To run it, you can use this code, and now we can see it will run on our local host, and this is what it looks like. Once you have built your Streamlit app, deploying it is a breeze. You can use platform like Streamlit Cloud to host your app with just few clicks. Alternatively, you can deploy it in your own server or cloud provider like AWS, Google Cloud, or Heroku. Streamlit is a powerful tool for building interactive, data-driven web apps without the complexity of traditional web development. Whether you are working on machine learning, data visualization, or business dashboards, Streamlit can help you build like deploy your apps quickly and easily. So this is the interface. Now I have made a browse button from which I can select .png, jpeg, .pdf files, and once I've selected it, it will process the image and give my desired output.